Here the problem asks us to write a recursive formula for each sequence. However, it doesn't identify whether it's an arithmetic or a geometric sequence, so we need to figure that out first. If we look at the first sequence, we see the difference between the first two numbers is 5, or a negative 5, and the difference between the next two is also a negative 5. So it's looking like this is probably going to be an arithmetic, and if we write down over here our formulas for both, our arithmetic, we would just take any term that we're interested in finding is going to equal our previous term plus some common difference d. And that common difference is found by taking the second term and subtracting from it the first term. And then for our geometric sequences, we have a very similar formula. Any term we're interested in finding, we take the previous term, but instead of adding a common difference, we multiply a common ratio. And that ratio is found by taking the second term in the series and dividing the first term, dividing it by the first term. So if we have a suspicion that it is an arithmetic, we will go ahead and take the second term, 21, and subtract from it 26, which equals a negative 5. This is what we think our common difference is. We can verify that it's a geometric by going through and checking it for at least twice here in the series. So if we are interested in the second term, we would take the first term, write that a little bit darker, first term, and subtract from it or add our common difference. So our second term is 21. We want to make sure that that is equal to the first term plus our common difference, our first term being 26 and our common difference being negative 5. 26 minus 5 is 21. So we would want to check one more time. The third term then, if we're interested in the third term, which is 16, we would take our second term, 21, subtract from it or add our common difference, which is negative 5. 21 minus 5 is 16. So we see it's an arithmetic sequence. And our first series, or the first term in the series, a sub 1, we have is right here. So we have our first term, our second term, third term, fourth term. This could be labeled f of 1 because we input 1, we get out 26. Or it could also be labeled a sub 1. Here, f of 2 or a sub 2, f of 3 or a sub 3, and so on. So a sub 1 is going to be 26 as our first term. And if we're writing the sequence, remember, for arithmetic, we're just interested in any term can be expressed as f of n or a sub n is equal to the previous term, which is equal to, in terms of a function of n, would be, the previous term would be f of n minus 1, or in terms of subscripts, we have a to the subscript n minus 1, or sub n minus 1. And then finally we add our common difference, which is a negative 5, so we would subtract 5, I'll put this up here, add our common difference, subtract 5, subtract 5. So either one of these is correct. Most of the time ALEKS is looking for your subscripts a sub n. And we notice that there's a qualifier, n must be greater than or equal to positive 2. You see that when you put in positive 2 in for n, you would get 2 minus 1, which would be a sub 1, which would give you the first term in the series. If n is less than that, we would be talking about terms less than the first term, which doesn't exist. if you plugged in 1, you would have a subscript 0, which would be the 0th term, which is not a thing. And that's why we have this qualifier, n is greater than or equal to 2. So we come over here to our second one. We look, well, the difference between 4 and 1 is a -3. If we subtract 3 from that, we don't get 1/4. So we have this sneaky suspicion that it's a geometric series, since those are the two series that we're working with. So in order to find out, we'll just take our second term, which is our second term here, our first term, third term, fourth term, also which can be expressed f of 1 or a sub 1, and so on, just the same as this other series that we did. So we can go ahead and fill in a sub 1 is equal to 4. So we'll take the second term in the series, which is 1, divide it by the first term, which is 4, and that should give us our common ratio. So our common ratio is going to be 1/4. And then in order to check to make sure we're a geometric series, we'll go ahead and look for our second term. Second term is going to be equal to the first term times our common ratio. So our second term in the series is 1, and that should be equal to our first term, which is 4, times our common ratio, which is 1/4. 4 times 1/4 is 1. That checks out. And we would want to check it one more time for accuracy. The third term in our series is 1/4. That should be equal to our previous term, which is our second term, which is 1, multiplied by our common ratio. 1 times 1/4 is 1/4. So it is a geometric series. We know for our geometric series, it's just any term we're interested in is equal to the previous term times the common ratio, real similar to our arithmetic. So the term itself can be expressed as either a function of n or a subscript n. And then our previous term, the same as before, f of n minus 1 or a subscript n minus 1. And then finally we multiply by our common ratio, which is 1/4. And you can leave it like this, or if you wanted to write it, f of n minus 1 all divided by 4, which is the same thing as multiplying by 1/4, or a subscript n minus 1 all over 4. Either way, these answers are correct.